Welcome, focused learners, to this explainer. Today we are diving deep and mastering 12th Chemistry Unit 8, Section 8.4 on ionic equilibrium. We're pulling this directly from the TOOT guide, specifically pages 70 EM and 71 EM. And just so you know, we are keeping every single chemical formula completely intact and tackling those all-important previous year questions. We're going to go line by line, and we'll be presenting all 17 source slides in a full-screen, cinematic manner so you can lock in and completely master the pH scale. Let's get to it.
Okay, let's dive into this agenda. We've got basics of the pH scale, mixing acid and base, calculating acid solutions, Kw and missing concentrations, the relation between pH and pOH, and finally, advanced solution calculations. This is basically our roadmap for the escalating complexity curve we're about to tackle, from basic definitions right up to advanced mixing problems.
Section 1. Basics of the pH scale, Foundations of Ionic Equilibrium. We are starting strictly with the foundational definitions and previous year, or PY, questions. Make sure your eyes are glued to the screen as we read exactly through the text here.
Question block. PMI 1, March 25. At 25 degrees Celsius, ionic product constant Kw of water is 1.00 times 10 to the power of negative 14. Its value at 40 degrees Celsius is A. 1.00 times 10 to the power of negative 14. B. 1.14 times 10 to the power of negative 15. C. 2.71 times 10 to the power of negative 14. D. 2.95 times 10 to the power of negative 15. Answer C. One-line explanation. As temperature increases, the dissociation of water increases, leading to a higher Kw value greater than 1.00 times 10 to the power of negative 14.
May 22nd, June 24, 25. 13. Define pH. It is defined as the negative logarithm of base 10 of the molar concentration of the hydronium ions present in the solution. pH equals negative log base 10 of H3O plus concentration, or pH equals negative log base 10 of H plus concentration. Log shortcut method general rule. For any concentration H plus equals A times 10 to the power of negative B, the shortcut to find pH is simply B minus log of A.
The pH scale, 1 to 14. 0 is stronger acid, 3.5 is weaker acid, 7 is neutral. Weaker base starts after 7, 10.5 is weaker base, 14 is stronger base.
Question block. PY 3, Mark 20. Write the pH value for the following substances: A. Vinegar, B. Black coffee, C. Baking soda, D. Soapy water. 1. A. Vinegar, 2.2. 2. B. Black coffee, 5.3. 3. C. Baking soda, 9. 4. D. Soapy water, 12. Action zone, log shortcut method. No log calculation needed here, but you can memorize the rule of thumb. Acids less than 7, bases greater than 7.
Section 2. Mixing acid and base, resultant pH calculations. Let's move along and see how this builds when we start mixing different volumes and concentrations.
Question block. 2. Following solutions were prepared by mixing different volumes of NaOH, of HCl different concentrations, pH of which one of them will be equal to 1. Options panel. I, 60 ml m by 10 HCl plus 40 ml m by 10 NaOH. I, 55 ml m by 10 HCl plus 45 ml m by 10 NaOH. V, 75 ml m by 5 HCl plus 25 ml m by 5 NaOH. IV, 100 ml m by 10 HCl plus 100 ml m by 10 NaOH. Answer panel. Answer D. I. One-line explanation. pH equals 1 requires H plus concentration equals 0.1 m. Only mixture 3 leaves exactly the right excess of millimoles of H plus per total volume to equal 10 to the power of negative 1 m.
Question block. 11. Equal volumes of 3 acid solutions of pH 1, 2, and 3 are mixed in a vessel. What will be the H plus ion concentration in the mixture? A. 3.7 times 10 to the power of negative 2. B. 10 to the power of negative 6. C. 0.111. D. None of these. Answer is A. One-line explanation. Average the concentrations 10 to the power of negative 1 plus 10 to the power of negative 2 plus 10 to the power of negative 3 divided by 3 to find the resulting molarity of approximately 3.7 times 10 to the power of negative 2 m.
Question block 15. What is the pH of the resulting solution when equal volumes of 0.1 m NaOH and 0.01 m HCl are mixed? A. 2.0, B. 3, C. 7.0, D. 12.65. Answer is D. One-line explanation. The strong base, 0.1 m, dominates the weak acid concentration, 0.01 m, leaving excess OH-, resulting in a highly basic pH greater than 12.
Section 3. Calculating acidic solutions. Direct pH applications. We are focusing purely on direct applications here to really lock those formulas into your brain. Question block, OG 21, 20. The pH of an aqueous solution is 0. The solution is A. Slightly acidic, B. Strongly acidic, C. Neutral, D. Basic. Answer is B. One-line explanation. A pH of 0 means H+ concentration equals 1 m, or 10 to the power of 0, which represents a very strongly acidic solution. Question block 7. A lab assistant prepared a solution by adding a calculated quantity of HCl gas at 25 degrees Celsius. To get a solution with H3O+ concentration equals 4 times 10 to the power of negative 5 m. Is the solution neutral or acidic or basic? pH equals negative log base 10 of H3O+ concentration. pH equals negative log of 4 times 10 to the power of negative 5. pH equals 5 minus log 4. pH equals 5 minus 0.6 equals 4.4, which is acidic. Log shortcut method. Bring the exponent 5 to the front, subtract the log of the coefficient 4 to get 5 minus 0.6 equals 4.4.
Question block 8. Calculate the pH of 0.04 m HNO3 solution. 0.04 becomes 4 times 10 to the power of negative 2. pH equals negative log base 10 of H3O+ concentration. pH equals negative log of 4 times 10 to the power of negative 2. pH equals 2 minus log 4. pH equals 2 minus 0.6 equals 1.4, which is acidic. Log shortcut method. Convert 0.04 to 4 times 10 to the power of negative 2. Drop the 2 down, subtract log of 4 to get 2 minus 0.6 equals 1.4.
Section 4. KW and missing concentrations. Finding unknowns. We're now going to use the ionic product constant of water to solve for missing concentrations. This is an absolutely crucial step for the board exams, so pay close attention. Question block. pH 4. June 23. Calculate the concentration of OH- in a fruit juice which contains 2 times 10 to the power of negative 3 m H3O+ ion. Identify the nature of the solution. OH- concentration equals Kw divided by H3O+ concentration. OH- concentration equals 1 times 10 to the power of negative 14 divided by 2 times 10 to the power of negative 3 equals 5 times 10 to the power of negative 12 m. H3O+ concentration is much greater than OH- concentration, so fruit juice is acidic nature. Log shortcut method. For finding missing concentrations via Kw, subtract exponents. Negative 14 minus negative 3 equals negative 11, and 1 divided by 2 equals 0.5, yielding 0.5 times 10 to the power of negative 11 or 5 times 10 to the power of negative 12. Question block. X. Calculate the pH of 10 to the power of negative 7 mHCl solution. pH equals negative log base 10 of H3O+ concentration. pH equals negative log of 10 to the power of negative 7 equals 7. Log shortcut method. When the coefficient is 1, as in 1 times 10 to the power of negative 7, the pH is simply the positive value of the exponent, 7.
Section 5. Relation between pH and pOH, the core derivation. So the crucial point is understanding the mathematical link between pH and pOH. Follow the logic exactly on this next one.
8.4.1. Relation between pH and pOH. Question block. Derive a relation between pH and pOH. pH equals negative log of H3O+ concentration. pOH equals negative log of OH- concentration. pH plus pOH equals negative log of H plus concentration minus log of OH minus concentration, which equals negative log of H plus concentration times OH minus concentration. pH plus pOH equals negative log of Kw. pH plus pOH equals pKw. pKw equals negative log of 1 times 10 to the power of negative 14, which equals 14 log 10, which equals 14. Therefore, pH plus pOH equals 14.
Section 6, Advanced Solution Calculations. Putting it all together, we've reached the final section. Everything we've covered gets combined here. Keep staying locked in for these final exam prep setups.
Question block, March 26, 14. Calculate the pH of 1.5 times 10 to the power of negative 3 m solution of BaOH2. BaOH2 dissociates into Ba2 plus 2OH minus. Concentration of hydroxide ion equals 2 times OH minus concentration equals 2 times 1.5 times 10 to the power of negative 3 m equals 3 times 10 to the power of negative 3 m. pOH equals negative log of 3 times 10 to the power of negative 3 equals 3 minus log 3 equals 3 minus 0.477 equals 2.5. pH equals 14 minus pOH equals 14 minus 2.5 equals 11.5. Log shortcut method. Base exponent 3 drops down. Subtract log of 3. Then subtract the resulting pOH from 14 to find pH.
Question block. Exam Prep Command Center. 15. 50 milliliters of 0.05 m HNO3 is added to 50 milliliters of 0.025 m KOH. Calculate the pH of the resultant solution. Millimoles of HNO3 equals 2.5, KOH equals 1.25, remaining HNO3 equals 1.25. Total volume equals 100 milliliters. Molarity equals 1.25 divided by 100 equals 1.25 times 10 to the power of negative 2. pH equals negative log of 1.25 times 10 to the power of negative 2 equals 2 minus log 1.25, which is approximately 2 minus 0.1 equals 1.9. Log shortcut method. Power of 2 drops down. Subtract log of 1.25, which is approximately 0.1, to instantly get 1.9.
Question block, 17. The pH of 10 to the power of negative 5 m KOH solution will be A. 9, B. 5, C. 19, D. None of these. Answer is A. One-line explanation. For KOH, pOH equals 5, so subtract from 14, using pH plus pOH equals 14 to get a pH of 9.
Question block. 6. The concentration of hydroxide ion in a water sample is found to be 2.5 times 10 to the power of negative 6 m. Identify the nature of the solution. pOH equals negative log base 10 of OH minus concentration. pOH equals negative log of 2.5 times 10 to the power of negative 6 equals 6 minus log 2.5 equals 6 minus 0.4 equals 5.6. pH equals 14 minus 5.6 equals 8.4. pH is greater than 7, solution is basic. Log shortcut method. Exponent 6 drops down. Subtract log of 2.5, which is 0.4. Convert pOH to pH by subtracting from 14. Which of these shortcuts will save you the most time on your upcoming exam?